For Algebra 1, you don't need to know this yet. Algebra 2, this is you, baby. All you. We have a function that's called a one-to-one function. And we have another function that's called onto. Function. Now, a one-to-one function says that every output has exactly one input. In other words, one domain item goes to one range item. Onto all the outputs have a corresponding input. In other words, nothing in the range is left untouched. Beautiful, beautiful, beautiful. Let me give you an example. A one-to-one, a not one-to-one, and an onto, and a not onto. Let's use letters, R-E-D. And R-E-D, R-E-D-S, and R-E-D-S. Numbers 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5. Alright, so for one-to-one, everything in the domain hits one thing in the range, and only one thing in the range. So this is 1-to-1. What's not one-to-one is if something in the domain hit something in the range twice. So this is not one-to-one. You actually have two going to one. Two different things going to one. One thing going to one thing, one thing going to one thing, one thing going to one thing. It doesn't really matter where D goes. Not one-to-one. Alright, onto. Now, onto is everything in the range needs to get touched without violating the whole function rule. This is onto. Everything got touched. This is not onto. It's not onto because you have two things going to one thing. That would be not one-to-one. It's not onto because we have two things left out. 5 and 4 did not get touched. Therefore, this is not onto. Now, it is possible to be one-to-one and onto at the same time. But before I get to that, let's try a full example with everything. Deciding whether it's a function or not, domain and range, whether it's onto, one-to-one, both, or neither. Mouthful. I need more paper. Okay. Let's see if you can see that. Before I move forward. Technical difficulties. Yep, you can see that. Alright. So, I have this set. These are set brackets. They look like little faces. And these are my ordered pairs. -6, -1, -5, -9, -3, -7, -1, 7, and 6, -9. The first question is this a function or not a function? A couple different ways to do it. You could graph it, you can do a mapping, you can do a table, you can do whatever you want. For me, I'm going to look at this and see if I have multiple x's going to, or one x going to multiple values. So to do that best, I think a mapping would be great. So this is my domain, which are my x values, and my range. So in my domain I have -6, -5, -3, -1, and +6. In my range I have my y values, -1, -9, -7, +7, and -9 again. So I'm not going to rewrite that. And then I draw some sweet arrows. -6 goes to -1. -5 goes to -9. -3 goes to -7. -1 goes to +7. And +6 goes to -9. This is a function because none of my values of x on my domain end up hitting two different things in the range. Like 6 only goes to one thing, -5 only goes to one thing, -3 only goes to one thing, -1 only goes to one thing, 6 goes to one thing. If -6 went to two different things, then that would not be a function. Okay, the next question is this graph onto, one-to-one, both, or neither? Okay, one-to-one is the easiest to do right off the bat. The idea is that everything just goes to one thing. There's nothing getting hit twice. Nothing's double timing. This is not one-to-one. Not one-to-one. You can look at it, think about it for a minute. It's not one-to-one because I have -9 getting hit twice. Not because -9 gets hit twice by -5 and +6. In other words, every output has exactly one input. This doesn't work because we have two inputs going to one output. Alright, so it's not one-to-one, so it can't be both. Is it onto? Now onto says that all the outputs have a corresponding input, or in layman's terms, nothing in the range is getting left out. Everything in this range gets hit. It has some arrow pointing to it. So this graph is onto. And you can write because all the range gets hit and nothing is left out. So it was not neither either. It's definitely on two. Okay. That, I believe, is it for the example of this loveliness. We're not done with the different types of functions there are.